to implement the ecological monitoring program for the county's MSCP. Jeff received his MS in Natural Resources from the University of Nevada, Reno in 2017 and BS from the University of California, San Diego in 2010. Jeff has been with the county for 2 years. So Brian and Jeff are going to be talking about water and riparian resource trends in the Ciénega Creek Natural Preserve. And I think we need the other mic.
Connie, Robert. All right, we'll give this a try here. Good morning. Thank you for being here. It's a pleasure to be here. Yeah, I'm going to have Larry's going to be my clicker. Got a guy with a PhD on the clicker. So, Karen mentioned that I used to be at OSC working with Julia, now working with Karen. I also worked with Nadine Behan. So I've worked with some pretty amazing people, some real visionaries in this watershed. And so it's a pleasure to actually talk about some of the data that's come from some of these visionary efforts over time. So go ahead and first slide. I'll get you to the presentation. Just talk about precipitation and drought, the stream flow measurements, discharge and water extent. Talk about some of the groundwater monitoring that's happened around the preserve, and how these data, which is just an amazing data set that's been started back in the 1980s, has continued to this day, how some of those data are used to inform management, used to inform planning processes, thinking about climate change, and also how it's been used for the assessment of the Rosemont line. And then Jeff will also talk about vegetation trends along the Ciénega Creek Preserve. So, next slide. All right, we've already got an introduction to Ciénega Creek Preserve, so I'll go ahead and Pima County Regional Flood Control District has a number of precipitation gauges throughout the Ciénega Valley. As was mentioned, most of the purpose of those gauges are for real-time measurement of precipitation for informing risk associated with flooding. However, the data sets are amazing. They're truly, you get data instantaneously, and so you can go onto the flood control website and download data for each one of these gauges. It's really easy, actually. It takes a couple minutes. Year by year, you can download data, or site by site. So a pretty amazing resource. So anyway, we have a precipitation going back all the way to 1990. You probably won't remember a lot about my presentation, so I'm just going to plant one seed, is that if you're really into data and if you really want to know that some great data exists, the great data exists for water resources in this area. So please remember that. Let's look at this. We have great precipitation data. We can see in the last couple of years we're actually a little bit above average, which is this line here. Next slide, please. All right, let's look at precipitation in two different seasons. This is winter and summer. And you can see the mean dots plus the standard deviation. There's a lot of variation there in those data. So there's no statistical trend downward necessarily. That you can see the variation in precipitation among those different gauges. It's pretty significant. However, the decline in precipitation is something that we've seen across the region, right? Particularly in the winter. And this really matches some of the climate change models that we're really seeing now, which is lower winter precipitation, summer precipitation, which is the next slide, please. Really not showing any trend at all. But again, a lot of variation. But this is, again, really consistent with some of the climate change models that are out there. So are we seeing long-term drought or climate change? The next slide is really quite stunning, actually. So there are a number of drought indices out there. This is called the Evaporative Demand Drought Index. There's a number of other indices out there. So this looks not just at precipitation, right, but also temperature and humidity and all these other variables. And what this is showing is that really since 2000, we are been in pretty extreme drought. So a lot of folks in this region, they talk about the 50s drought, right, as a really significant drought, for example. And that's true. The rainfall was actually quite low in the 1950s. But if you consider other factors like temperature, the drought of the 1950s was actually a relatively cool drought. And what we're seeing now is not just drought, but they're hot droughts. And that creates a lot of problems for vegetation and for aquatic resources. So it's important to keep that in mind. It's not just lower rainfall, but also higher temperatures. And next slide, please. Okay, so we have precipitation gauges. We also have two different water volume measurements that have been taken over time. I'm just going to talk about this one gauge, a USGS gauge at the Pantano Dam. Julia talked about this area where that dam was put in. This USGS gauge has been collecting data for quite a while. There's also, by the way, the flood control district also has stream gauges on Davidson Canyon and Ciénega Creek further upstream. So those are very important resources for data. But anyway, this is the Pantano gauge looking at trends since the 1990s, and you can really see that it's declined significantly over time. Next slide, please. But then if we look a little bit closer, and this is mean annual, so this is taking a lot of data. This gauge collects data every like 10 minutes or 15 minutes. So this is compressing an entire year into one data point, but this is looking at trends at different times of the year. And again, looking at the winter precipitation, the January and the April compared to the September, you can really see the decline in water that's passing that one particular point in time.
What's the beginning year on that? Or
Yeah, this is 1990, if we go back to this, yeah, this is 1990. This gauge goes back, I think, to 1966. So there's a wealth of data there. Next slide, please. Okay, so stream flow extent. This is really an important measure and something that a lot of folks in our region are interested in now. We hear a lot about these wet-dry mapping efforts. And this is a picture of me doing her annual or quarterly walkthrough at Ciénega Creek Preserve. And I'll talk about the data in a second, but I think it's really important to recognize that every single one of these data points here, every one was that me and or other people were actually walking the entire length of Ciénega Creek. So this isn't just some gauge measuring. This is independent, consistent, long-term, and dedicated effort on the part of a lot of people. And I think that's important to remember. We tend to think about data as this sort of static thing that just kind of, it's out there. But it's really a heart and soul of people who've dedicated a lot of time to this. But with that said, we're also seeing a significant decrease in the extent of flow in Ciénega Creek. So Ciénega Creek Preserve has 9.5 miles in it of stream flow, 9.5 miles of stream, if you will. So if you think back in the 1980s and 90s, relatively wet period, there was water. You would walk there in June or in January, September, and there was water there the entire length. That has declined significantly. We'll get into the seasonal piece of that in the next slide, please. And Jeff's going to get up here in a second and show you a really cool demonstration of this loss of extent or the dynamic system that we have here. But this is really important. This is in the dry summer. We call it dry summer. We like to say in the Sonora Desert we have 5 seasons, and the summer broken up into the pre-monsoon and the post-monsoon. We call it the dry summer. So this is June, and you can really get a sense of dedication of people who are doing this work, right? That they're out there at this time of year walking 9.5 miles to map the extent of water in the preserve. But look at this line. Look at it going from 8.5 miles back in the 90s. So we're just getting a little over a mile. There was one data point there, I think it was 0.85 miles of stream flow. So really a significant decline over time. So that was a dry summer. We'll go to the next slide. Oh, sorry. I thought there was another slide in there. But I'm going to hand it over to Jeff. He's going to talk about a little more about that, and then about how some of the data are used in some of the modeling efforts. Thanks, Brian.
So, as Brian said, he showed you with the data. The flow is so variable on an annual basis. We wanted to actually show you what this looked like. So this is a zoom into the Pantano Dam. Anyway, there's a small private parcel here in the upper left-hand corner of the image that is the Pantano Dam diversion. And you can see basically the red lines now cycling through. This is on. Sorry. Let's see if you can't go back. Okay.
Let's jump into the next slide, Jeff.
Can you click back one, please?
Yeah.
So anyway, this can go through 1 second per year for 20 years from 1989 to 2018. And basically show you the sort of amount of change on an annual basis just above the Pantano Dam. So if you can click. Please.
That's not working. It's not running the animation. Sorry.
There we go.
Oh, there it is.
This will cycle through again. You're looking at about 1 mile of stream reach, but how variable this is on an annual basis, and how fractured it becomes, where some of these reaches are microscopic relative to the length of the entire reserve. And again, as Brian said, all of this is mapped on foot by staff on a quarterly basis. So next slide, please. And we're not just seeing this trend at one location. We have stream gauge and groundwater monitoring well data from across the reserve. So we're seeing these downward trends across the reserve. Next slide, please. If we look at, this is an annual average or mean depth to groundwater for 2 monitoring wells that are shallow groundwater monitoring wells, one in Ciénega Creek and one in Davidson. You can see that there's generally somewhat of a downward trend, but conveniently, especially in Davidson, in the last several years, we've been seeing some recovery in those shallow groundwater wells, which is really nice to see. If you keep 2008 in mind, and this will relate to the last slide or two, basically where we saw this peak, sort of an increase in pulse flows, increase in precipitation. Next slide, please. We can also, with these groundwater wells, shallow groundwater wells, paired with the stream gauges, we can pick up real-time pulse flows. And so here you can see discharge on the top, and then discharge on the bottom in the gray and black, and then the well depth, shallow groundwater well depth, the colors on the top. And you can see that the shallow groundwater wells are essentially picking up the pulse flow events in real time. And so we can pair that, next slide please, look at a correlation between surface flow from our mapping efforts, pulse flow events, and depth to groundwater. So we have these really tight correlations between surface flow or surface flow extent and depth to groundwater in the reserve, which is really nice because, next slide please, we can then use that to model potential impacts if we were to reduce surface flow from a project like Rosemont Mine. And you can model how responses at different parts of the preserve, or different locations in the preserve, might change as a function of decreasing surface water flow. Next slide, please. This figure is from the BO for the Rosemont Mine. And it's a little challenging to see, but generally the trend lines that are on the bottom of the figure are lower down in the Ciénega Creek Preserve, whereas the 2 or 3 lines at the top are in upper Ciénega Creek. And essentially, what this means is that there are modeled disproportionately higher impacts or decreases in surface water flow lower in the Ciénega Creek National Preserve, so lower in the watershed as opposed to upper in the watershed. And that makes sense. If we're cutting off flows from Davidson, we're likely to see more impacts below Davidson again. Next slide, please. And what we're starting to do is look at this in the context of changing vegetation over time. So Julia showed you those great time series photos, photo point monitoring in the reserve, take the photo at multiple points year after year, and you can visually see change in vegetation structure. We don't have that sort of drastic change on an annual basis now because the forest, the Cottonwood Gallery Forest is there. But one of the things we're trying to look at is how, if we can use remote sense indices to detect sort of smaller changes in vegetation composition and structure over time on an annual basis. So again, this is looking at the Pantano Dam, or just above the Pantano Dam, an aerial imagery shot, and then remotely sensed index from Landfire, which is estimating percent cover by functional group. So that'll say 30 to 40% tree cover within that cell, 20% shrub cover. And by sampling those over time, you can look at how those are changing. Again, we're using this as a proxy, but if you look at the figure on the right, you can see that there are 4 time periods. The first is from 2001 to 2008. The second is from 2008 to 2010. And in that time period, we're seeing almost 30% of the sampled cells within the Ciénega Creek National Preserve show an increase in percent cover within their relative functional groups. And we're thinking that that correlates with that increase in precipitation, or increase in flow, excuse me, during that time period, where after that flow decreases, we have a sort of drop again in percent cover of those same cells over time, likely back down to somewhat of an equilibrium based on that lower amount of flow. And so as these data products become more available over time, whether or not it's Landfire or National Data Set, we're planning on using these for long-term ecological monitoring and assessing how riparian forest structure is changing over time. So, thank you.
We have time for one question.
Let's use the mic for the question.
That's okay. Somebody have a question?
Got them all convinced?
Okay.